Okay, so I made up this data. The thing that's not made up is the molarity of the sodium hydroxide. It's 0.11585 molar. That's a standard solution, so I made it very, very carefully and calculated the molarity exactly. What I did was I created an initial burette volume of 1.50 and a final burette volume of 19.75. Just as an example, I made up these numbers. So in order to find the milliliters, the volume of the base that I have, I'm going to take my final burette and I'm going to subtract my initial burette. And when I do that, I get 18.25 milliliters. Now, in order to change anything into liters, I have to divide by 1,000. So I'm going to take out a calculator and divide 18.25 divided by 1,000 to get the volume of the base. And when I do that, I get 0.01825 liters. Now, the key concept here is this idea of moles of base. So I'm going to transition just so I can show my work. And I know that moles equals molarity times volume. Well, let's look at what I have for my base. I know the molarity of my base. So molarity is this number right here, the 0.11585. And for the base, it will always be 0.11585 molar. And then the volume has to be in liters in order to get moles. So that's why I converted it. So my volume is, this is what I just calculated, 0.01825 liters. That's the thing I just calculated when I did my volume in milliliters divided by 1,000. So when I multiply these two numbers together, I get my answer of 0.00211 moles of NaOH. Now the key principle here, and I'm going to transfer that over here into my chart, moles of base, 0.00211. Well, the key idea in a titration is that moles of base equals moles of acid. So right now, I'm going to say that my moles of acid also has to be 0.00211. Because if they're equal, then it will be a neutralization reaction. I have no extra base, no extra acid. Now there's one thing I do need to change. I did not use 0.0250 liters of acid. I only used 10 milliliters instead of 25, so I do need to change that to be 0.010 liters. Now it wants me to find, and I actually do need to change that across the entire board. It wants me to find the acid concentration, and I'm going to use the same equation, except now I know the volume of my acid and I know moles, and I need to find concentration. So let's go back to our calculations. We know, based on our molarity triangle, that molarity, or concentration, M, equals moles over liters. Well, if I look back on my chart, I have moles of acid and I have liters, so I'm just going to plug those numbers in. So molarity equals my moles, 0.00211 moles divided by my liters, 0.010 liters. And I put that in my calculator, and I get a molarity of the acid to be 0.211 molar HCl. And so that's what I would put in my acid concentration. Now, when I do average concentration, I'm going to average all of my concentrations that I get, and I'm only going to get one number for the average. So you'll have done 4 trials, you'll get 4 different concentrations of the acid, and then you're going to find the average. Now, what I will tell you is that this acid is supposed to be 0.200 molar acid. So what you're going to do is you're going to find the percent error in your lab notebook. And percent error is determined by how you spell error. So you take the experimental value you got in your experiment, you subtract the real value, and you divide by the real value. ERR spells error. So experimental is whatever you got. In this experiment, I just got 0.211. Then I subtract the real value. Well, I just told you the real value is 0.200. And then I divide by the real value, 0.200. And then, of course, to make it into a percent, I have to multiply by 100. So when I do that in my calculator, I get 5.71% error. And that's really, really good. Anything less than 10% error means I did a pretty good job with my trials. Now, obviously, these are just my made-up numbers, so your numbers would be different. Your assignment for today's class is to make sure that you have done all your calculations, including percent error, answered the pre-lab questions, and answered the post-lab questions.